Hi, so today we're going to look at volume of prisms and cylinders. So volume is the space inside an object. So if we go back to this bottle again, so previously we looked at the bottle and we talked about total surface area around the outside. Volume is the space inside. So if I was to open, how much water can I fit in there, or how much room is in there essentially. So when we look at volume, we look at the space inside an object. So we'll just do an example for rectangular prism. So we'll say that is 5 centimeters, 5 centimeters, and 7 centimeters, right? The formula for a rectangular prism is length by width by height. If we go over here, this is the length, this is the width, this is the height. Substitute next, so it's 5 times 7 times 5, 5 times 7 times 5, and finally you solve. So Mr. Robinson has kindly helped me out and shown me how to add the calculator to my screen. So hopefully this works. Thank you, Mr. Robinson. So 5, maybe it doesn't. Technical difficulties, and I'm going to just have to go back old school for a second. If you bear with me. 5 times 7 times 5, press enter, answer is 175, as you can see clearly on the board. So I type in 175 here, my answer is 175, and because it's volume, it's the space inside, so you're multiplying 3 numbers, so therefore it's centimeters, and it's always cubed, centimeters cubed for volume. Let's make those outlines a bit harder, deeper. So that's for a rectangular prism. I'm now going to go a triangular prism. So imagine you've got a triangle here, and then you got a prism coming off it. Again, my drawings aren't amazing. So that line should be dotted. I got it wrong way around. So imagine this is 2 centimeters. The height of the triangle is 5 centimeters, and then the length this way is 6 centimeters, 7 centimeters, let's say 7 centimeters, right? So the area of a triangle we should know from before. So the area of a triangle is half base times height, and basically what we're doing here is imagine that series of triangles is stacked on top of each other and go all the way up to length here, so times length. So if we said this is the base, this is the height, and this is the length, it's a bit hard to see, huh? I might need a better light. So here 2, so it's half, base is 2 times height is 5 times 7, so 35 times 2 is 70, half of 70 is 35, so it's 35 centimeters cubed. So, and then lastly but definitely not least, we're going to move on to a cylinder. So again here, cylinder is a circle, just basically a circle stacked on top of each other. So if you think about that, we know pi r squared is the area of a circle. If you just stack circles on top of each other, and I call that h, it's pi r squared h, that's the formula. So let's say the radius here is 3 centimeters, the height is 9, so this is the radius, this is the height, then we substitute, so we got 2, substitute, pi 3 squared times 9 And then again I use the calculator, so I'm just going to bring the calculator bigger onto the screen. So it's pi 3 squared times, what did I say, 9. Enter, and then I got the pi answer. So then I press Control Enter on the calculator and I get a real answer. So my real answer is not real answer, just sometimes they ask for different ones. And as you can see here in the decimal place is 0.469. So if it's 9, it goes up 1.467. So again here, if I come back to my page, you see I've already written in this answer. I've got the wrong screen here. How do I make that smaller? There's a lot going on. And I've actually already wrote in my answer here, so it's 254.47. And again here, I didn't write centimeters here, but it was centimeters. So it's centimeters, and because it's volume, it's centimeters cubed. So as you can see from all the answers, centimeters cubed, centimeters cubed, centimeters cubed. I will work on the lighting and see if I can get better set up. But again, I'm pretty new to this, so you got to understand it's a learning curve. Similar to you, it's not always going to be perfect. Again, we're just going to, hopefully grow. We'll constantly model that growth mindset of learning from our mistakes, getting better. Asking for help. Like I said, I asked Mr. Robinson how to get the calculator up. So see if he has a more succinct way of filming, because I think he's the pro in this one. So if you see him in the yard, say hi. Take it easy.